As we have completed the algorithm and pseudocode that is applicable for binary search, let's try to write the JavaScript implementation for it. For that, inside this searching folder, I'm going to create a new file. Let's say the file name is binary search.js. Okay. Inside this file, I'm going to define a class binary search. Okay. Inside this class, I'm going to define a function called binary search. Okay, and it will take two arguments. One is the array and the second is the value that I want to search. Okay, a small disclaimer that you have to remember is here we are assuming that the values in the array are sorted in the ascending order. Okay, if the values are sorted in descending order, there is a slight code exchange that we need to do that I'll explain later anyway. But whatever the logic that we are writing as part of this function will honor the array when the array is sorted in the ascending order, when we are trying to search a value inside the array which is sorted in ascending order. Okay, with that, what we have discussed as part of pseudocode, we will be defining two variables, which is min, which represents the starting point of the index in the array, which is always 0, and we will also define which is the ending index, which is nothing but max index, that is nothing but array dot length minus 1, and we will also be defining one variable called mid, and we will assign it to -1 now, and later on in the comparison when we calculate the mid, we will use this value for holding that middle index. Now as long as while min is always less than or equal to max, then that means that min and max have still not overlapped. That means that there are still some indexes that needs to be searched inside the array. Once they overlap, that indicates basically we have searched all the indexes in the array. That's why I'm comparing it with min is less than or equal to max. As long as this condition is matched, what we have to do, we have to calculate the mid. How we will get the mid? We will get mid by dividing the min plus max divided by 2. Okay, but in JavaScript, the integer division could give us floating point results. So what we will do, we will floor it to math.floor of this result. Now the mid variable will hold the whole integers, which is nothing but the middle index. Now what we will do, we will simply compare the middle indexed value, which is nothing but ARR of mid. If it is equal to the value that user has passed, that means that is available at the middle index. So we will simply return -1. Okay, if this is not the case, that means there could be two scenarios, right? Since the array is sorted in the ascending order, whatever the value we have in the mid could be larger than this value, or the value we have in the middle index could be smaller than the value that user has passed. If at all, if the value at the middle, that is ARR of mid, if it is greater than the value that user has passed, that means whatever the value we have in the mid is greater than the value that user has passed. That means whatever the value that user wants to search is available on the left part of the array. How we will search in the left part of the array? We will search it by updating max to mid -1. Okay, otherwise that means whatever the value we have in the middle index is smaller than the value that user has passed. That means whatever the user wants to search is available on the right part of the array. So what we will do, we will simply start from mid +1 index. Start index is nothing but min. Min is nothing but mid +1. Okay, so I mentioned in the beginning that the array is sorted in the ascending order, right? If the array is sorted in the descending order, all you have to do is you will have to exchange line number 13 and line number 15. Line number 15 should go into line number 13, line number 13 should come into line number 15, because the array is sorted in the descending order. Okay, make sure that you are taking care of this case. Once we complete this while loop, right, that basically indicates that we have searched each and every possible index in the array that could hold the value that user has passed. If this loop is completed, that indicates that the value is not available, so we will simply return -1 in that case. Okay, this is how we basically implement the binary searching algorithm. Now let's try to create an object. Let's assume that the array that I want to use are basically 1 2 3 4 5 6, and the value, let's say const value that I want to search is, let's say 20, okay, which is basically not available. Technically, if we run this function, we should basically get -1. Let's create a function. Let's create an object const bs equal to new binary search. From this bs, call the binary search function and pass the array and the value that I want to search. Now this is basically returning the result, right? So let's hold that index result inside the variable index, and let's just log that so that we can validate it. Okay, so all I have done is created the object, called that index, called the binary search function, and stored that return value inside the variable index and just printing that. Now we will simply do node searching binary search.js. Okay, since 20 is not available in the array, we have got -1 here. Okay, similarly, let's say I want to search for the value 2, which is available at index 1. So if we run the program, we should get, we've got -1. Why? Got the issue here. If the middle index has the value that user wants to search, it is available at mid index, right? So we should return mid here. So that is the mistake I made. So if I run the program once again, I should get the index 1. Okay. Similarly, let's say the array might contain some duplicates, which is 3 3. Since the array is sorted in the ascending order, if we are trying to return 3, it should basically return whatever the index that it processes or reaches first. So 3, 0, 1, 2, 3. So it reached the index 3 first. So it returned the index 3 because 3 is available at these two indexes. Okay. Similarly, you can go ahead and you can write your own implementation when the array is sorted in the descending order. Okay. I will leave it to you. You can go ahead and implement it. Just remember that you just have to exchange the lines of code that I have mentioned earlier. Okay. This is how we basically execute the binary search algorithm using JavaScript.